The last graph in your practice packet is for a double line graph. We have used line graphs before when we are graphing two sets of quantitative data, one on the x and one on the y. But if you have more than that, you're probably going to need to make a double line graph because you have multiple sets of either the independent variable or dependent variable in the experiment. So if you have multiple sets of quantitative data on a data table like you see here, you have the numbers for the year versus two sets of numbers for the population, then you'll need to make a line graph with two lines on it to represent this data. So double line graphs are good for multiple sets of quantitative data. This data table shows the populations of two cities, Bayview and Delta, each year from 1996 to 2003. Since there's no title for that on the data table, I need to take this information from the description and use it for my title on the graph. Next, I need to label the x and y axes with the independent and dependent variable. So looking at this situation, the population number depends on the year that you're looking at. So the population number is the dependent variable and the year is the independent variable. And from our dry mix acronym, we know that the dependent responding variable goes on the y and the manipulated independent variable goes on the x. So I'm going to label the x-axis year and the y-axis for the population. Now we need scales for the graph. Looking at the x-axis, my years, I have 1, 2, 3, 4, 5, 6, 7, 8 years. And I've got 20 boxes to work with again. So 20 divided by 8 is about 2 point something. But I know that to evenly space these out, I need about 2 boxes in between my years for the scale down here. So that's what I've used. Every 2 boxes is a year. For the y-axis, this is a little more complicated. I have to look at this data and decide. I'm going to start at 0, and I need to go to the highest data point for any of these cities. And so the very highest data point that I have is 645, right here. So I need to go from 0 to 645, and I've got 20 spaces to do it. So I can't count by tens and get there. I would only get to 200. I can't count by 20s or 25s. I'm going to need to count by 50s. So that's what I've done down here. Taking 650, dividing that by 50 means that I needed 13 boxes, which I have enough of those if I do this. Finally, you're just plotting x and y coordinates for each city. So starting with Bayview, in 1996 the value of the population was 450. I placed a dot there. Then 1997 it was 460, 1998 440. So I drew in all of the data points for Bayview's population, and then I connected those to show the trend. I did the same thing with Delta, using a different color so that both of the lines on my graph would not be the same color. That way I could provide a key to distinguish between which population trend line was for Bayview and which one was for Delta. So finally, all you need to do is do your self-checks. We have a title on our graph. The axes, we have the independent variable on the x, dependent on the y. We have labels for both of those. The key for this one is to color code the 2 lines on the graph. And finally, scale factors. I have my x-axis evenly spaced. My y-axis is evenly spaced and the numbers are counted consistently by 50s. My graph is taking up at least 50% of the space that I have provided. So it looks like everything for scale checks out. I hope that this practice has helped you learn some more about how to make an appropriate graph. Make sure that you study the study guide for your graphing quiz.